Okay, so let's talk about vectors. Vectors are a value with two qualities, magnitude and direction. So we'll talk about it later on how to find magnitude and direction. But yeah, that's what a vector is. So how do you write a vector in form? So this is vector form. You have this symbol here and then the v, and these are the coordinates. So the number on the left represents the x length of the vector. So basically along the x-axis, the horizontal length of the vector, and the second number is the y length. So in this case, we have the vector 2, 5. So what would that mean on a graph? So if we have a regular standard graph here, since we have an x length of 2, we'd go 1. First of all, we'd have to find our initial point, which we have our initial point set at 0, 0, the origin. So our initial point is right here. So using our vector form, we see that the x length needs to be 2. So 1, 2. And then our y length needs to be 5. So up from 5. 1, 2, 3, 4, 5. So, and then we mark a dot here. And what that dot represents is the terminal point. And that is the end of the vector. So we draw a line from the initial point to the terminal point, and that's what our vector looks like on a standard graph. The second thing you have to know is linear form, how to write a vector in linear form. So obviously you can turn your vector into a line and plug in values. So if we were to turn this vector into linear form, it would be 2i plus 5j. 2i is a horizontal component, and 5j is a vertical component. So let's talk about the magnitude and direction part of the vector. So magnitude, how we find the magnitude of a vector is basically just the length of the vector. So in this case, how do you find the length of a line? We use the distance formula. So we're going to do the same thing here. The distance formula is, as we know, y2 minus y1 squared plus x2 minus x1 squared, and then the square root of all of that. So let's just use our points here. Remember the vector is this, 2, 5. So 5 is the y value, we know that. And we're using 2, 5 here, and then the origin 0, 0. So the y2 value is 5, y1 value is 0 because we're using the origin. So 5 minus 0, and then here the x value is 2, x value of the origin is 0. So 2 minus 0, you get that. So keep plugging it in, we plugged it in. 5 minus 0 squared is 25, 2 minus 0 squared is 4, 25 plus 4, 29, square root of that. So that's how we find the magnitude. The magnitude of this vector is the square root of 29. Okay, let's talk about the direction. So direction is basically how we find the direction is just the angle underneath the vector. So we can see a little data sign here. If we think of this vector as a line, and then the x-axis as the thing that's covering the other side of theta, the other side of the angle, then this data value is the direction. So how would we find that data value? Well, we know from our sine, cosine, and tangent functions that the tan of theta should be opposite over adjacent. So our opposite is the length of the vector, 5. If we made a hypothetical triangle here, the opposite is 5, and the adjacent is 2, right? So if we know that tan theta is opposite over adjacent, then we say tan theta is 5 over 2. So after we have to solve with theta, so we take the arctan of both sides, theta equals arctan 5 halves, and that gives us 68.199 degrees northeast. Sorry, that should be northeast. And that gives us the direction and the angle. And another way to find direction actually for vectors is by using slope. So we know that our y value, our y increase is 5, and our x increase is 2, so the slope would be 5 halves. We know that from basic algebra, and so that's another way to say the direction of the vector. Okay, so let's talk about vector operations. So what are the different things you can do with more than one vector? So you can do some of these different operations like addition, subtraction, multiplication, but remember you cannot do division. So if you have more than one vector, you can add them together, you can subtract them from each other, you can multiply them, do not divide. So let's try out some of these. Let's try the subtraction one. So we have vector u here, vector u is negative 2, 5, and vector v is 3, 4. So let's subtract vector v, let's subtract vector u from vector v. So vector v minus vector u. How would that look like? So what we do for these subtraction operations is we literally take the x value of the v, we take the x value of the first one, and subtract the x value of the second one. So how would that look like for here? For the x value, the x component of this operation, we take, since it's v minus u, 3 minus negative 2. And you guys know 3 minus minus 2 is going to end up as 5. So that's what the x component of our subtraction will look like. And then for the y component, we take, since it's v minus u, 4 minus 5. So that would be 4 minus 5 is negative 1. So that would be the y component of our subtraction. So this is what vector v minus vector u, this is the vector that would ensue. And then let's do another one. Let's do multiplication. So one thing you can do to vectors is you can actually not only multiply vectors by each other, which would look like multiplying the x component of one vector by the x component of another one, and you would get that, but you can also multiply vectors by a constant. And this constant is known as a scalar quantity. So what does that mean? For example, let's take 5 times, let's multiply vector u by the scalar quantity of 5. And what that would look like, it's really simple. You just multiply the x and y components by that constant, by 5. So we have negative 2, 5 here as the original u vector. So let's multiply by 5. Negative 2 times 5 is negative 10. 5 times 5 is 25. And that's how we get 5 vector u. And then, for example, I didn't write it down, but if you want to do vector u times vector v, it'd be negative 2 times 3, which is negative 6. And then you just remember 5 times 4 is 20. So it'd be vector u times vector v would be negative 6, 20. And that's how you do vector operations. So one of the other things you might have to do with vectors is figure out if 2 different vectors are equal to each other. So remember that a vector is composed of magnitude and direction. So how do we know if 2 vectors are equal to each other? They are equal to each other if 2 vectors have the same magnitude and the same directions. Then and only then are they equal. So we have 2 example vectors here. We have vector v, which has the initial point 1, 2 and the terminal point 6, 4. And we have our old friend vector u, which has the initial point at 0, 0, the origin, and terminal point 5, 2. So let's find their magnitude and directions and see if they're equal. So for magnitude, remember, we use a distance formula, right? It's just the length of the vector. So 4 minus 2 squared, let's just plug it in. 6 minus 1 squared will give us square root of 29 as the magnitude for this one. And for direction, we're going to use the slope for the direction this time. So 4 minus 2, for the slope formula, obviously you guys should know. 4 minus 2 over 6 minus 1 gives us a slope of 2 over 5. So that's our direction. So let's go over to vector u and see if we have the same ones. So for vector u, plug the points into the distance formula. 2 minus 0 squared plus 5 minus 0 squared gives us a square root of 29. And for direction, the slope, 2 minus 0 over 5 minus 0 gives us a slope of 2 over 5. So if you don't know how I got the magnitude and direction, look at the video or look before to see how I found those. But now we see that the magnitude for both of them are equal to the square root of 29, and the directions are equal to 2 over 5. So these vectors are equal.